All right, everybody, welcome tonight to our Git and GitHub lecture. First thing I want to do is gauge everyone's knowledge of Git and GitHub. So right in the chat, if you could just throw from 0 to 5, how comfortable you are with Git and GitHub together. So 0 being you have no clue what they are. 1 being you've heard of them, but you never really use them. 1 being you've done some stuff through the Learnco gem. I guess 2 being you've done some stuff manually. 3 being you do everything manually. 4 being maybe you've done some advanced commands like bisects and stuff like that, or have used those and know what they are. And then 5 being like you can teach it to a newbie, no problem. Okay, 2 to 3, 1, 2, 1 to 2, 2, 2-ish, 3 to 4, 2. Okay, so with that base of knowledge, I'm going to, I know this study group is tagged, intermediate, advanced, but every time I've done this study group, I've never found anyone who's considered themselves intermediate or advanced or really had the basics down. So let's go through, I think we can go through some of the basics, and we can probably get to inducing a merge commit and walking through that after going through some of the parts of it. And yeah, we'll see how time goes with this. But we'll just start with what Git is. So Git is a free, as the homepage is going to say, free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. So Git is a protocol. So Git itself is not a version control repository. Like, your code doesn't live in Git. Git is just something that helps keep track of it and keep track of changes and keep track of who has what and who's done what and such. So Git is just the protocol. Like HTTP is a protocol, or TCP/IP is a protocol. It's a protocol that was written by somebody. I'm sure we could find it. But so Git's a protocol. There's tons of documentation out there about it. Everybody implements Git just a little bit differently, but the main commands work across the spectrum. So you've probably heard of GitHub. And GitHub is the largest of the version control systems that people know of and that people use, I think. A lot of the open source GitHub, mainly because public projects are free, no matter how large they are. So that's what's drawn its attention to a lot of the large open source projects. However, there are others out there. And in addition, there's other version control systems out there besides Git. So just real quick, Bitbucket is a similar product like GitHub. This is by Atlassian. So so that you've heard of some of these other options that are out there. They also have a free thing. So if you want to, put some of your code up on Bitbucket and see how it works, that's cool. A lot of companies use Atlassian products. So if they're in that ecosystem, they might be using Bitbucket. Gitlab is another one that is open source, and Gitlab's difference is that they allow you to host private repositories for free, and you have to pay for public ones. So they're kind of the opposite of GitHub. So GitLab is cool if you have a bunch of things that you want to have in private repositories, and you don't have some sort of account on GitHub, because you have to pay GitHub if you want private repository access. Another version control system is called Team Foundation Server, and that is by Microsoft. So if you're working in a .NET ecosystem, your company in the future might be using TFS, as it's called for short. I know a few different places that use this tool, so it's not something that's completely uncommon. It just really depends on what your company's doing. And then you can also, companies can roll their own. Like I said, Git is a protocol, so there's nothing holding a company back from creating their own Git server and doing it themselves. And then finally, we have GitHub, the one that I'm logged into currently. But yeah, the GitHub, the one that we're most familiar with, the one that all of the Learnco curriculum has its code hosted on. So that's a real quick overview of what Git is and how, not even how it works, but what it is. And let me get a good image of Git branching model. Sorry, I usually have this queued up, but like I said, I was getting prepped for a different lecture. I just realized right when I went to paste this, which lecture I was doing. There's the one that I've used in the past. Git, I think it's Git flow, not branching model. Git flow. It's a really good one. I'll have to save it for next time. I know it's in here. It can look, here we go. Perfect. And view image. There we go. So the thought is with Git that let's think of what would happen if, let's say, I had some code and you had some code, and I update something in the code and it works, and then you update something in your copy of the code. How do we not step on each other's toes? How do we make sure that the code is always up to date, that you're not doing something I'm doing, that we're not causing conflicts, that, and if you have a third person, even if you have one copy that's on the server, then you're always trying to keep up with what's on the server, and you have to copy it. You're always copying and trying to overwrite things, and you can't work on the same files and such. So version control solves that problem. So the idea is that there's a master branch. It might not always be called master. Master is the most common, and some companies might call it production or something like that. But there's a branch that is always the so-called working one, the one that you have out there for the public. And that's the one that you want to protect, so to speak, from bugs, from things that don't work. You want to make sure that one's always good. So when we start working in teams, we're going to typically have branches. So you'll take a branch, and GitHub has this little branch icon that it has for things, and that's going to create a copy of all the code at that point in time. And it doesn't actually like physically move it around, but visually, it branches it off. So you can do work. These little dots are supposed to be representative of commits. You can do a commit and another commit, another commit. So your commits are moments in time where you've added some changes to the code, and we'll go through that. And then the master branch is not being touched at all. It's not changing. It's doing its thing. And then you open a pull request, and a pull request is saying, hey, I've created this new feature, I've done whatever, I've added a page, I've fixed a bug. So here's a pull request. And then the pull request typically will go through some code review. So there's comments back and forth, and you make some more code changes based on the code review. Then finally everyone's saying, okay, it looks good, we know it works, it's passing tests, everything's looking good on it, it does exactly what we need, the code's looking clean, and everything's right, and it gets merged. And then all that code gets added to the master branch. And now that branch is gone, and it's part of master. Now the idea is that there can be multiple branches going on at the same time, and as those are being merged at different times, the version control system helps mitigate issues with that. So let's say 7 different features get added, the version control system is going to intelligently merge the code together, or as intelligently as it can, merge the code together for us and help us with all that. Now there are times that it won't be able to figure out what to pick, and that's what a merge conflict is, and we'll see if we can get there this evening. So we can look at one of those, because that's probably the scariest thing that people run into when they first start dealing with Git, outside of just some of the Stack Overflow answers that you'll find when you look for Git solutions to things, because it does get very technical, and it has a ton of features, just like something like Rails has a ton of features, and some people know it really, really, really well. And because of that, there are some really obscure commands that some people know and use that we just, on the day-to-day, I can tell you that 99% of the time, I think there's, I wrote them down. There are 2, 4, 6, like 9 commands that you really are going to be using all the time. And then the rest of the stuff is done through the interface. So I think a good activity to go through will be showing everybody, and you can go through this together as we do this, what happens when we fork or when we open a lab on Learn. And it does a lot of things in the background for us, so we're going to just walk through that manually to see what's happening. Okay, so head over to Learn. Oh, by the way, I forgot in my little intro, any questions you have throughout I guess the next 45-ish minutes, please just shout them out, unmute yourself if you feel like it. If you're not in a place to do that or don't want to do that, feel free to just throw it in the chat window and I will get to it. I promise. I sometimes get zoned into my second screen, which is and I don't look back to the chat window, but I promise that I will get to that if in time. Yeah, not if, I will. So looks like I used this one before. So let's get to a lab that hasn't been forked yet and isn't a README. Okay, keep on. One of these will be a lab. Really? Okay, finally, a lab. So the Learnco gem does a lot of things for us, and it's very nice. I don't suggest just abandoning it. It's really useful, and it will save you a ton of time. I used it through the entire curriculum. There's no reason not to, but understanding exactly what it's doing is definitely helpful. And knowing that, you know, it's just saving us some time and what we're going to have to be doing in the end when you're in the workplace, what's going on is going to be useful for you. So if we are on a lab, you can hit this Open in GitHub lab or Open in GitHub icon, and it's going to take you to the parent lab. So this is the repository, as it's called, a repo for short. And a repository is just a place where code lives. It's a place where code lives on a server. So different from it living on your computer, the repository is living on the server. And what we first need to do is fork. So when you fork a lab, what happens is you're going to make a copy of all the code in its current state and put it into your account. So with me, you're going to see a lot more options. I'm part of what are called some organizations. So I can actually make copies to any of these organizations. You're probably not even going to have these options. If you do, then you just pick the one you want. I'm going to pick my personal one. And it's going to take a second. So it's forking it. It's making a copy right now. OK, so now there's a copy, and we see we have my username here, and we have forked from, and it says where the parent is. And it's always going to be connected to that here so that we can do things later. So now the next thing we want to do is get this code from the GitHub server onto our local computer. So what we need to do is clone this code. So we want to make a copy of it somewhere else. So we're going to hit green clone button, and there's a button right here for copying to clipboard. So I'm going to click that. And then I have my text editor open. And you could do this in the Learn IDE. You can do it in the in-browser IDE, just the same in the terminal. Well, I guess the in-browser IDE is going to open it all for you because it's linked like that. But you go to where you want to put your code, and the code is going to download into a folder that's the same name as the repository. So we have this JS-data structures-structures-array-lab-v-000. And if we look right now, I'm just going to do a ls to list all the folders, and we get nothing back because there's no folders. So the first command is going to be git clone, and then we want to put in that URL that we just copied from GitHub. And we hit enter. We see cloning into, and that's the folder that it's cloning into. And it tells us a remote and some other info. I don't know that I've ever really dove into any of this, honestly. but that's where all of the stuff is going to come down to. So now if we look at our folders, we see we have one folder. So I'm going to change into that folder, data structures, dash arrays, dash lab, dash v000. I must have spelled something wrong. And there we go. So now we're in this folder, and we see all the code, the things that were on the server. Everything that's here, we see here with the one test folder. So now I'm going to, well, first, let's go back to Learn, and we should see if we refresh. Okay, so we see the green light forked this lab. And that actually happened before it was cloned. Just once it got forked over here, it was moved, and Learn picks that up. And I'm not honestly sure the technology behind how Learn knows when things are forked and how it keeps up with that. I'm sure they have some cool integration with the API that they're calling and figuring it out. But that's the first step. So we've cloned it. The next thing we need to do is run any install. So that's going to be either bundle or npm install. Since I'm in the JavaScript section of the curriculum for this, so I'll do npm install, and that's part of the process. If you run the IDE, you'll see that this happens automatically. You also see that the Learnco gem gets installed automatically to make sure that it's there. So these are things that are happening automatically for us, but it's good to know exactly what's going on behind the scenes. So we want to run the install. I'm probably gonna get a little pop-up that my hard drive is running out of space because it keeps telling me that, even though it isn't. Okay, so there is all of our dependencies. A note for anybody who's working on their own computer and working locally, these node modules can end up taking up a ton of space. There's a lot of stuff in them, and I remember that they were like 200 or 300 megs each. So when you do like 50 or 100 labs, they do add up slowly but surely over time. And with that, you might get into a space where hard drive space is limited, but once you're done with the lab, you can delete these folders and they're fine. You can always just run npm install again and you get everything back just the way it was. It's just all those files that were just installed by npm install or yarn, if somebody does that instead. We see this actually installed that gem also. So with this, we get all that installed, and now we should be able to run some tests. Now, to get this local test light to turn on, you have to use the Learnco gem. That's the only way that works. So even if you're running a local environment, you do have to use the Learnco gem to run your tests. So everything, oh. Hopefully you never screw up your REM gem set and have to do that every single time. I still haven't figured out how to fix that. Learn. And there's our tests, our failing tests. So just close that. I'm closing this. And let's go through some other Git commands now that we have a repository. I'm just going to clear this. And let's make this a little bit bigger. Maybe one less. OK. Actually, close that down and make this one more bigger. There we go. Larger, I guess, is more proper terminology. So a few of the Git commands that I was telling you were going to be most often used. So Git Clone is the first one of them. Git Status is going to be a big one. So Git Status is going to tell you your current state of what you're doing. So we see it tells us we're on branch master. A little bit earlier, I was talking about those branches that you could be working on. Currently working on brancher or on branch master. Branch is up to date. It's telling it we're up to date with the origin master, and we'll go through what those are. Nothing to commit, working tree clean. So this origin master is talking about the remote repository. So something that we can look at is git remote, and it needs a little flag -v for verbose. I honestly don't know why you do git remote without it being verbose, because you wouldn't be able to see it. But still, it's there. And now we see this origin. So we have origin here twice. And it's showing us two remotes for different things. So we have a fetch and a push. So when we did git clone, we were bringing down the fetch. And when we have code that we want to add and get to the server, we're going to push it. And here we see this Git protocol. We see git at, and that's the protocol little piece. And then we see the server, github.com. And then we have my username, and then we have the name of the repository, and then .git. So that's where that information comes from. So this origin is the remote, and then master is the branch. So you can have multiple remotes. I know people who have set up a remote on Gitlab and a remote on GitHub, and they push everything to 2 locations just because they want that redundancy. It's something that you can do. I don't. So Git status is always going to tell us the state of where we're at. Grab a pen so I remember what we've been through on my little sheet here, stuff to talk about. Okay. Okay, next thing that we want to do is we might want to, or we will, change some code. So I'm going to go into one of these files and change some stuff. Obviously not trying to pass any tests, but okay. So we have a file and it's been saved and changed. Now, what we need to do, and depending on your IDE, you might not have to do all these commands, but knowing them I think is good. Like you see, I'm using Visual Studio Code, the same editor that is used and it allows us to add commit messages and to revert and discard and stage and push and pull and do all these things for us visually. So get accustomed with whatever version or whatever your IDE offers. There are also some other GUI tools which I will point out before we're done tonight to interact with Git. And okay, so now, like I said, Git status is our best friend. It's going to give us all types of info. It's also going to give us next steps a lot of the time so that we don't forget what we need to do. So Git status, on branch master, branch is up to date. Okay, those two things haven't changed, but it says changes not staged for commit. Use git add file to update what will be committed. Use git checkout -- file to discard changes in working directory. No changes added to commit. Use git add or git commit -a. So the first thing that we need to do is add this file. Well, this file has technically already been added, so it's actually a modified file. If we created a brand new file, I'll just create a new file, and we do git status again, we'll see we have two different types of files. We have a modified file and an untracked file. And this is significant just for one reason, that there is a shortcut command that you can't do on completely new files. So you have to add all files first initially to include them into the version control. So right now, this index is in version control and this new file is not. So we want to add that. So we can do git add new file.js. I didn't camel case that file, but it's okay. Now if we do git status, we see two different things. We see changes to be committed because this file has been added and is ready to be committed. We see changes not staged. This file is already in version control, but it hasn't been added to this commit. So it hasn't been staged and is ready to get committed. So we can do git add period, and that's a shortcut for git add all. It'll add everything that's either not staged or not added. So it would have added both of these files. So we get everything ready and check our status again. Okay, 2 files ready to be committed. So we have git commit. Now git commit is going to let us add a message, and our flag is -m for a message. Now, this is where we see 29 commits. We're adding a commit. And this is where these messages are added. Pluralize title, remove your unlock from Git tracking, improve test, merge branch master. All of these messages are commit messages. So commits are a moment in time of your code. And if you've worked on any of the projects yet, you're supposed to do commit often and for small incremental code changes. So, you know, changed instruction comment would be a perfectly fine commit. And it has to be in quotes. And enter. And we'll see 2 files changed, 1 insertion. This is lines of code. So we've added 1 line of code, inserted it. It has some more info. Look at our status now. On branch master, your branch is ahead of origin master by 1 commit. So it's telling us that our local copy has 1 commit more than what's on the server. Nothing to commit, working tree clone. So something else that I don't think a lot of people use, however, it's good to know that it's there, is I should be able to see it somewhere. I want to show visually and then show how to do it in the, oh, I know what I can do. Let's just go to README. I don't suggest editing many things through GitHub. I do it sometimes for READMEs just because they're there. When you edit this file, if you know Markdown, you can just write Markdown and be done with it. There's a title and this description. And you can add this description through the command line as well. I'm going to cancel there. Just go back to here. Commit. So let's go back and look at this. Oh, also, it's a best practice. And I don't know any, like, I've never actually tried to, you know, quote unquote, keep to this, but just naturally you'll fall into it. Commit messages, the titles should be short. So they should be less than or equal to 72 characters. And then we want to do git commit. Also, you want to use this if you mess up. So if you have a misspelling in your commit, you can do this. And it's git commit -- append. Oh, maybe I hit the wrong message. Append, git commit. What is it? It's just message? No, that's what we did. I'm sure it was append. Amend. Getting my commands wrong. Like I said, if you type something wrong, it's going to tell you that you typed something wrong, but it's also going to give helpful info. So, amend. That's going to pop open your default editor. In my terminal, the default editor is Nano, something that just comes with, I think, Linux systems. So here's the comment. And then if I wanted to, I could include a body. If I just enter twice, and there's my optional body, optional message. So we can do it. Including a body for show. And I'll save that. And that's there. So append or amend It shows how often it's used that I didn't even remember the exact wording of it. It can be used to change commits. Messages is really the key to know about that. Now that we have some changes, we want to get those onto the remote server. So we're going to do Git Push. And in any repository that you clone it down, all you need to do is Git Push. You'll probably see Git Push -u, origin master, and a lot of other commands. But once you have a repository that you clone down, you can just do Git Push, and it pushes it up to the server. So now if we go and look at our server and refresh, well, we probably don't need to refresh because I'm going to click a new file. But if we click index, we see there's 2 lines here. When we go back, need to refresh this page now. We see new file is here. We also see the commit message is next to them. If we look at the commits, we'll see here's this commit. And if we click, we see there's a body to the message. We also have this little hash key. If we click that, it's going to take us and show us what changed. So here's the little green highlight for this line of code was added. If code was removed, it's highlighted in red. It shows the new file was added. It says when. It has the full commit hash, which is this long number. And that is what happens when we push our code. So we're still here at this point, and we've pushed our code up, but now we want to get to this submit pull request part. So if we look, we see right here, this branch is 1 commit ahead of Learnco Students Master. So Learnco Students Master is our parent. Just open this in a new tab. So Learnco Students is the user, and master is the branch that we copied from, that we forked from, and now that we've added some new code to. So we need to do this pull request. So we click this button, and it's going to do what starting a pull request. So we'll look and make sure that we're choosing the right target. We see our little left arrow here. And it's saying we want to take the code from here, which is my copy of the repository. And we're proposing to merge it to the parent. So we hit create pull request. It's going to include, if you have 1 commit, it'll include that. If not, I think it includes the last commit. But typically, the Learnco gem will create done. And you hit create pull request. Now we've created a pull request, and if this wasn't a Learnco repository, if it was an open source project or something, or at work where you're working, then there might be reviewers, there might be people assigned to it, there might be labels and projects and milestones, there might be automated tests that start happening right here. I can show some of that on another repository that I have. Pull requests. So we see like had a new NYC devs list. So this closes an issue, and here's the commits that she put in. Here's me merging the branch, and then I found some things that I thought could be changed. So these are the reviews. So it's right here on this piece of code, and here's a little comment. Then down here we have checks. So these are different checks. This is some tests that are automated, that run automatically, and this is a little deploy script, and there's some other stuff. But you might see all these things going on. And that's where these little check marks come from. When the integrated tests pass, they're green. When they don't, they're red. I think some of these are red. Yeah. Webpack is at 4.1. It just got upgraded from 3 point something, and it broke a bunch of stuff. So the Webpack version is not working right now. But those are things that you'll see. And then eventually we saw in the little image, have some discussion back and forth, and you'll probably have a senior developer or another developer on the team say, you know, hey, let's clean this up, let's use this. This isn't the most performant, so we should change it to this. Leave comments all over the code, and don't worry, it's a great learning experience. And then you fix all those things, you learn lots about better ways of doing things, and when all that stuff is done, they'll say, okay, good to go, and it'll be merged in. In our instance, it's not going to be merged in because that's not what happens with these labs. So I'm just going to close this so it's not just sitting out there and get rid of it. And that is the entire process of kind of everything that goes on when you do learn open and learn submit. Those two commands do all of those things for us. And then test. So we see we've got submitted pull request that's been figured out. And then this forked, this lab part. So these two things are done. Oh, this even has no link on it. Never noticed that. That takes you to your repository of it. So now, also want to show, where is this repository? I guess I'll just go back. Refresh. So like I was saying, the Git status will tell you lots of things. So I'm going to go ahead and actually change this. Just get rid of that. Remove link. Also, you can probably drive yourself crazy with how to format a commit message. Everybody, there's like guides out there and everybody is very opinionated by it, but really I think it's really going to be up to the team that you end up working on. I've adapted this capitalized first letter, no period at the end type of thing. But some people will say you're supposed to have proper punctuation, so you want to put a period at the end. Some people will say it doesn't matter at all. I really like to put emojis into mine when I can, just for fun, because it gets boring writing code for hours on end sometimes. So either way, just feel out your team, and there's probably going to be lots of standards for that based on the team that you're on. So now we've changed something on the remote. On the repository that's on the server, something has changed. And it might not be our change, it might be somebody else's change. So if we do git status, we see we're one commit behind. It says use git pull to update your local branch. So another one of our commands, we did git push before, is going to be git pull. So we do git pull, and we see one file changed, 2 deletions because we deleted 2 lines, and that file is updated. I wanted to actually have it open. We can do that one more time, and I'll show you. So the file will actually update in real time in your editor, or it should. I'll just take away its title. Commit. And I'll do git pull. So we have arrays right here, and that should disappear. Boom, it's gone. And now the code's up to date with what's on the server with git pull. Now, I was talking about branches before and using branches in the workplace. And yeah, I think we're good. Just looking at the time. Should be able to get through everything else, just not too long. So a branch is going to allow us to do changes to code without changing master. So to create a branch, well, if you just type git branch, it's going to tell you all the branches on your local machine. So there could be 1,000 branches up on the server. Everybody's working on different things. Your local machine, you're not going to have copies of all that stuff. That would take up a lot of space. So you have your local branch, git branch. So when you want to create a new branch, type git branch, new branch. And that's how we create a new branch. And then we can do git branch again. We'll see we have 2 new branches, or 2 branches now. And there we go. The branch will be created from whatever branch you are on at that moment in time with the code that is on that branch. So it's always important to remember that. I made the mistake a couple times of I was doing code reviews of somebody else's code and it wasn't in a useful state. And then I created a branch from that and did a whole feature and went to submit it and it was like, oh, I have all this code. And that person had finished those features and merged it to master. And now I had all these conflicts because my code and their code was different on something that they had worked on. And I had to parse through it all and figure out what was supposed to be there. So new branch, to switch branches is git checkout and the name of the branch. And now anything that we did on this new branch, I guess that's a bad name, this branch will not affect master at all. And if we do git push, okay, that took a second for whatever reason. You see new branch and it pushed the new branch up even though we didn't make any changes. And we can see now, once we refresh, that there's another branch here. So that's branch. To get rid of a branch, you want to get off of that branch. You get branch -d is the flag and the name of the branch. And it deleted that branch from the local machine. It's still up on the server, didn't go anywhere there. That has to be done a different way. And there's all these things here, so delete. And there's probably a way to do that through the terminal. I just, for some reason, I guess I feel more comfortable doing stuff on the server through the website and stuff on my local machine through the terminal. Got that. So if you're wondering about creating new repositories, because you're going to have to do that for projects, you have to do it through the website. Well, the easiest way I think to do it is through the website. You're always going to have to do something through the website. And you hit new repository. You want to give it a name. So new project. And you can add a license here. And that'll automatically add the license for you. It's very nifty because I always end up not doing it and just copying and pasting anyway. You can add a git ignore, which you can look into. That's to not include files on GitHub that are just unnecessary. It's like that node modules folder. It's typically in a git ignore because that's going to be specific to the person that installs that. You know, we have this package JSON and this package lock JSON, and that's going to tell people what versions of files to install. So we don't need to include all the files with it. They're going to run npm install or yarn, and it's going to install all these modules for them. So there's no point in keeping them in our version control and just using up space. So we're going to create the repository. Here, let's say Java, oh, maybe node. There we go. Create repository. And with that, we got our license in here already. Got our git ignore in here. And that didn't show the things that I wanted. Okay, let's do this one more time. Another project, and we'll just hit create without either of those. Okay, this is the screen I was looking for. That's very useful. So it's going to give you the steps, step by step. Git and GitHub are very useful in giving you all the commands you need. So if you didn't have a folder that you had already been working on your computer, you can go through all of this. This echo another project, and to readme is going to create a readme file and put this another project in it. So you don't have to do that. Git init is how you initialize a repository. So if we go down here, and let me go back one folder, and say, let's create this project folder, project. And right now, if we do git status, we're not going to get anything, not a git repository. So might as well make this file real quick so that I have something in it. It's not going to let me push if there's no file. So that should have created that file. So Git init is what turns this into a Git repository. So we still don't have a repository. So when we git init, initialize empty Git repository. There we go. So now the rest of the things we have to add, we have to commit, we have to add the remote, because since we created this locally, it doesn't know yet where our server is and where we want to put this code. And then we have to push it explicitly to origin and master the first time. We want to set that up. I guess I can't select all of these at once. So let's do this real quick. Oh, that's not going to work. Okay. Git commit. Just show that this connects. If you already have an existing repository, so you've already done Git commit, you already have files, or Git init, you already have files in it, it's already set up and ready to go. You just have to add the remote and push the first time. And that's what this second set of code is. And then there's, if you've done this before, here's your info here's your link. And that's all that you really need, because you probably got this memorized. Git, where are we at? Add, commit. So the remote add, like I was saying before, if we look at git remote -v, we don't have any yet. So when we add the remote, git remote -v is going to give us both of our remotes now. We're going to push. If we try and push right now, no, it worked fine. So I guess the -u origin part is taken care of. I'm not sure why there's that there when it works without it. I thought the first time you had to do the -u origin, but I guess not. If we refresh, have a README up here with the one line in it that we created. So if you already had a repository, click here, copy it, clone it down. And those are all the main Git functions that you need to know, commands. So to review what they are, let me actually need to go up one folder. What folder am I in? Oh, there we go. That's fine. So commands that are good, that are key to Git. Git init, Git clone, Git add, Git commit, Git push, Git status for sure, Git pull, Git branch, Git checkout, and then the flags, -d. Sometimes you'll get an error that the remote hasn't been merged, but if you really just want to get rid of it from your local, and it's going to tell you this, -D. To add the message, Git commit -m for our message. If you're interested, Git remote -v, although that one is typically set up for you because you're working with an already established repository. So yeah, what is that? That's 9 with 2 different flags. So I guess you're never really going to use this one without a flag. So kind of 8 total, or I guess 9 total, that you really are going to be the core of all of your Git usage. Any questions that I can answer? I know we kind of blew through that. I wanted to try and show examples of all the most common things that we do with Git, but it is kind of dense. So yeah, questions until we're done. A lot of this is also muscle memory. You're going to, if you think about writing code full time, the number of commits that you're going to write, the number of times you're going to push and pull and do these things, it's going to become second nature very quickly. So don't fear if it seems like there's a lot. There is, but it becomes second nature very, very quickly because it's very repetitive. Unfortunately, this is one part that we can't automate for ourselves. It's just something we have to do. Yes. Having a little notepad with what they are. I watched Yana do a GitHub study group, and she had actually set up aliases in her terminal. So like Git Push and Git Commit was just like GC and GP and such. And that really helped her be more efficient because she was doing the things so often. It also helped her because, you know, she was like, okay, the things that I do most often, I can make aliases for. So it helped her kind of assess herself in what was most commonly used. So thank you. Really enjoyed this evening.